Hey guys, Philip from Mindcode here. The lecture you're about to see is taken from Mindcode Academy course, so if you're looking for a broader context, you can find it at Mindcode Academy. But there shouldn't be any problem when you will watch it without watching the course, because it's very generic concept. In this lecture, we'll continue. Actually, this lecture will be AI lecture, so additional information lecture, and I will be explaining in the details how layer mask works, and also why we are performing here this operation of the negation of the zero, how bitwise operators work, and how binary system work, and of course this if statement what we are performing here. Okay, so without any further waiting, let's start. Of course, you are free to skip this lecture if you already understand these topics, but for all of the other guys, we can stay and we can try to understand it together. Okay, so let's go back to Unity, and the first thing what we can check for, let's click on the bandit. Let's check how their layers are stored. Okay, so let's click on the layer, enemy, and simply add the layer here. We don't need to add anything, but we can see how they are here displayed. So we have a layer from the 0, the layer 31, which means in a total 32 layers, and every layer has a specific number attached to it. Okay, so layer 8 has a different number, layer 6 have a different number, layer 30 has a different number, and so on and so on. To see this, actually, we can go back to coding editors and remember your enemy is on the layer 6. Let's go back to coding editors and let's debug log here this layer. So debug log here the target layers value. So target layers value. All right. Okay, let's save this. Let's go back to Unity. Okay, let's play the game, and as I will hit the enemy, you will see the number. Okay, this will be the layer in which the enemy is. Okay, so you can see the enemy layer, this layer 6 has a 64 number attached to it. So this layer 6 represents number 64. Why is that? Okay, to understand this, we need to first understand the binary system. Okay, so let's go back to, actually I don't need to go anywhere, but I will go here to Photoshop, and actually I have here some drawings, we can remove them. All right, and we'll start over again. All right, so our layer mask information is stored into the one number, into integer 32. So the layer mask informations are stored in the 32 bits. So this is the int 32. That's how your layers how your layers are stored. So you have a 32 bits. So you can imagine here 0 and another 32 zeros or ones. Okay, your binary number can be 1, 0, 1, 1, 0, 0, 0, 1, and different combinations of 1 and 0. But in total, you would have 32 of these numbers. Okay, this means that this number is an int 32 integer on the 32 bits. The length of the integer is at 32 bits. 32 ones and zeros, and your layer mask is as the integer 32. So you have a 32 ones and zeros, and each 0 and the 1 represent your layer. So now let's imagine our particular case of our two target layer that we have on bandit. So in a bandit we have here, actually on a melee weapon here on a sword one, we have our melee weapon script, and we have targets layer, and we are targeting only, from all these layers, we are targeting only enemy layer. So two targets layer holding only enemy. This means our layer mask holds 32 bits, so 32 zeros, 0, 0, 0, okay. I'll display here the last 7 values, so this will be 1 and 0, 0, 0, 0, so 1, 2, 3, 4, 5, 6. Okay, so this number, the first one here from the right side, represent a layer. This is the layer 0, this is the layer 1, this is the layer 2, layer 3, layer 4, layer 5, layer 6. Okay, this should be here, layer 5, layer 6. Okay, so layers. Okay, so you have a 32-bit number represented by the zeros and the 1. If only your target layer has a targeting only enemy layer, this means your layer mask will be 32 zeros, only 1, 1 on the position of the 6. Okay, so 0, 1, 2, 3, 4, 5, 6. And now, as we saw, the 64, that's a representation in a base 10 system. Here we have a binary system. So how can we transform this from the binary into the base 10 system? First, we need to understand how the binary is transformed to the base 10 system. So let's imagine number, let's say 4-bit number. This is a 4-bit number. It has only 4 bits and only ones. Okay, so this is a base 2 system, binary system, base 2. How you would transform it into base 2? How you would transform it into the base 10? Okay, so each bit holds a different value. Since it's a base 2 system, this first bit is holding value of a 2 on 0, the power of 0. The second one holds the 2 on the power of 1. The third one, 2 on the power of 2. And the fourth one, 2 on the power of 3. 2 on the power of 1 is 1. 2 on the power of the 1 is 2. 2 on the power of 2 is 4. 2 on the power of 3 is 8. You can see already pattern here. So this number here, or this 4-bit number holding only ones here, would represent the number 1 plus 2 plus 4 plus 8, which is 8 plus 4 is 12. 12 plus 2 is 14, plus 1 is 15. So this would be 15 in the binary, in the base 10, okay? So 15 in a base 10, and in a binary 1, 1, 1, 1, 1. Okay, so three ones. Okay, in a base 2 system, 1, 1, 1, 1 is the same as a 15 in a base 10 system. Now you can use this information and you can transform any binary number into the base 10 number. So for example, you have a number like this, 1, 0, 1, 0. What it would be in a base 10 system? Now you can guess. Okay, you don't need to guess, but you can compute it. Okay, so here again, the first bit holds the value 1, the second bit holds the value 2, the third one holds value 4, the fourth one holds value 8. So now you have only 2 active bits here, all of the other ones are zeros, so this means this value we don't need to take in account, and also this value we don't need to take in account. We have only 2 active bits, so 1, 1 here, so this is 8 plus 2. So that's the value of 10. So this 4-bit number, 1, 0, 1, 0, would represent in a base 10 number 10. All right, so now with this information, we can transform it into this here. So again, this first bit holds value 1, the second one holds value 2, this is a value 4, this is value 8. Now this will be 2 on the power of 4 in this, so this will be 16, but you can already see here pattern, so this is 16. This one is 32, and this one is 64. All right, so you can see already that's why we are holding the 64, and that's why you saw this 64 into debug log here. All right, so for example, if I would select here multiple layers, so not only here enemy layer, but let's say also I would select here water layer. So now in my 2 target layer mask, I have selected here water and the enemy. The number will be different now, okay? So let's see here layers, how they are displayed. So we have here enemy, this is a layer 6, and here we have water. Water is layer 4. So that would be already a different number, right? So if you would like to transform it here, it will look like this. So this is their enemy, 1, 0, and another 0, 0. So 1, 2, 3, 4, 5, 6. Okay, so water is on the layer of the 4. So layer 0, layer 1, layer 2, layer 3, layer 4. So this will be, since we are also targeting water, so this 0 would become 1. Okay, so that would be our layer mask representing when we are targeting only enemy and the water layer. Okay, so this you can imagine also 0, so 32 bits. All right, we are only selecting enemy on the layer 6 and the water on the layer 4. So what is this number? So again, you can see here that would be 64. That would be 64, and this layer is 16. All right, so 64 plus 16, that's 80. Okay, so that would be, this would be 80. 64 plus 16 is 80. We can verify it. we can select here. So already the voter is selected, so your sort should have here already voter and enemy. So I will play the game and I will try to hit the enemy. Cleared it out. Let's play here and let's see. You can see the value is indeed 80. So that's how it's stored. All right, so now with this information, you can actually transform any binary number to normal Bayesian system. But let's take a look on the specific examples here. Okay, so specific example here, why we are writing here this negation, this is a negation operator of the 0. So here we should provide the layer mask. Here on the sphere cast node alloc, this should be integer of the layer mask. So what's the representation of the 0 in the binary? Okay, in the 32 bits. How you would represent 0 in the 32 bits? You would represent the 0 basically with a 0 and another 31 zeros. Okay, so you would have here 32 zeros. When you're using this operator, this tilde operator as a negation operator, what you are basically doing, you are flipping the bits. So if you have a bit 0, this will become 1. If you would have a bit 1, it will become 0. So what will happen from all of these bits, what you will get when you will flip them, you will get only ones. So you will get here 32 ones. Okay, so flipping 0 means you will get 32 ones in the layer mask, which means in this case, when we are providing here sphere cast non-alloc, we are just saying here that we would like to hit every layer here. We are basically allowing to hit every layer. Okay, so that's what this check says here. All right, so that's the check here. And now let's take a look on the check here. Okay, this will be slightly more complex. Okay, so targets layers value and operator and the bit shift operator here. We are shifting number of what our layer is in which number. We are shifting it on the number of the 1 to the left side. Okay, this will be slightly more complicated. Okay, so what's the number 1 in a binary? Okay. Let's first understand what's the number 1 in the binary. So again, I can already remove some of the things here. I think this is clear. This is clear, right? So what's the number 1 in the binary? Number 1 in the binary in the 32 bits means that you have basically 31 zeros. And this last, or depends how you look at it, the first bit is a 1. This represents number 1. So 31 zeros. These are 31 zeros. 31 zeros, and here you have a 1 bit. Okay, so let's just display, let's say, last 10 spots or last 10 spots of this number. Okay, so you'll just see here last 10 spots of number. So the number 0, 0, 0, 0, 0. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that would be number 1. Of course, you have also other zeros in the front. In total, you should have a 32, but I will just display last 10 bits. Okay, so last 10 bits. This is the number 1. That's what we are writing here. Okay, the number 1 here. Then we are shifting. So we are using this operator, shift operator, left shift operator, and we are shifting here. Okay, let me see. We are shifting here. Other game object layer. Okay, so we are checking on which layer is our other game object. Okay, so what we are hitting in this case, enemy. All right, so we are hitting here, hitting here bandit, and bandit is in the layer of the enemy, which is basically the sixth layer, right? It's a layer number 6. We can also display this information, so we can see here, right here, debug lock, and we'll get here other game object layer. So we will get here the layer of the game object is in. You will get here integer of this. So other game object layer. Okay, we can hide all the other informations. We just want to see in which layer is the object. So let's see it. All right, let's go to Unity. Let's try to hit the enemy. All right, so let's see. So I'll try to hit the enemy. Okay, you can see layer 6. Okay, so this number here, when you are accessing here game object and you're checking for a layer, this will get you actual number of the in which layer the enemy is. Okay, this will not get you 64 or something like this. This is not the layer mask. This is actual in which layer the enemy is. So what we are doing here, we would like to shift this. By the 6. So this number here, this 0, 0, 0, 0, 0, and 31 zeros, and the 1, we would like to shift 6 spots to the left. What does it mean to shift it to 6 spots to the left? You mean that you will shift every bit 6 times to the left. Better to imagine it, I will show you the example. Okay, let me find here bitwise operators. There was very good. All right, I think I will. I had one resource, guys. Give me a second. I will just place here this resource. There is operators tut plus. I think it was here on this website. Yes, so there is very good image I would like to show you. It's a bitwise operator here. Okay, here. So if you have these bits, this means basically you are shifting it 3 spots. In this case, it's the number 37, shifting 3 spots to the left. So all these bits is moving to the 3 spots to the left. This means these first 3 bits are basically falling down, and all of the remaining bits are replaced by the zeros. You would get just the zeros. So you are just moving everything 3 spots to the left side. That's the left shift operator. So basically, when I have this number 0, 0, 0, 0, 0, 0, 31 zeros and 1, 1, which represents 1, and I'm shifting it 6 spots to the left, I will shift it like this will go 6 times here. So from this number, I will basically, what I will get here will be 0, 0, 0, 0, and the 1, and the 0, 0, 0. How many spots I have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and this one is on the position of the 6. Actually, it should be 7. Okay, I need to switch to bits here. This should be like this. 1 and 0. Okay, so when you are shifting it 6 spots to the left, here you will have a number 0, 0, 0, 1, 0, 0, 0, 0, 0. So this one is moved basically 6 spots here to the left, and you will get this number, which again, this number represents 64 as your layer, the enemy layer. Okay, so now we know this number here, when we are shifting here, let me see, 1, we are shifting the 6 spots to the layer. Okay, we'll get this number here. Okay, so we had this number here, 1, shifting 6 spots, we are getting this number here, you can see down. Okay, and now we are providing here logical operator and, which are two targets layer value. Our targets layer value is currently that we are targeting here. We are currently targeting, let's click on the sword, we are currently targeting, where is a melee weapon? We are targeting water and the enemy. Okay, so our layer mask, if you would just want to see the last 10 bits, our layer mask would look like this. What we have here we would have here 0, 0, 0. We are targeting enemies, so number 1. All right. Then we are targeting here is a 0. Here is a water on the layer 4, and then 0, 0, 0, 0. So we have here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so 10 bits. Now we are using operator AND. All right, AND, which is logical operator AND, which is if we have 2 bits, from that you need to add them together, but you will get from the 2 bits only the 1 if the both of them are 1. If one of these bits is 0, it will become 0. If there is 1 and 0, it will become 0 again. So if you want to get the number 1, you need to have 2 bits to have a value 1. So now we will use here operator AND. Here is your layer you are hitting. This is your enemy, and here is what you are targeting layer. So AND operator 0 and the 0 is 0, 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 1 and 0 is 0, 0 and 0 is 0, 0 and the 1 is 1, 0, 0, 0. So So this is the result, basically, of the AND operation. You are getting here this value again. You are getting here value 64. Okay, it will get you 64. Okay, and the 64 is not equal to the 1. So this means you are hitting the correct layer, because if it would be equal to the 1, you would be hitting basically the other layer, and you would return here. Okay, so that's basically how it works. So you can see also example. When you will go back to Unity, I'll click here on the sort, and I will say here I'm targeting only the water layer. So I'll unselect the enemy. So I'm currently I'm targeting here water. Okay, so the same stuff here. We are shifting this game object layer here, what we are hitting. So in the case we are hitting enemy, we are hitting the 6th layer. So we are moving these 6 spots to the left, and targeting here layer, we are targeting only water. So you can imagine here in this example, so here is our layer we are hitting, that this is our enemy. This represents our enemy, and here is our mask, what we are allowing to hit. But in this case, this will be 0, because we are targeting only water, and water is layer 4. So this will be the one here. Now we can perform the AND operator, and you will see this will be now 0, 0. You can see everywhere 0, 0, 0 is 0, 0, and 0 is 0, 0 and 0 is 0, 1 and 0 is 0, 0 and 0 is 0, 0, 0, 0, 0. So 10 zeros, and that's equal of 0. That's a 0. Okay, so you can see now when we are targeting water, indeed, this will equal to the 0. That's why we are returning, and that's basically that's the entire targeting system. So they're just playing with the 1s and 0s. So your layer mask has a 32 bits, is represented by this int 32 number. When you have a 32 combinations of the 1 and 0s, each layer represent value 1 if you are targeting the layer. If you're not targeting the layer mask will stay at 0. Okay, so in the case, as you show the examples, if we are targeting the water and the enemy, and the water is layer 4 and the enemy is layer 6, then the combinations of the 1 and 0s will be different. So the bit here, the 7-bit basically here will be 1, and the 50-bit will be 1. And then we are just computing here. We are using here AND operator on both of these numbers. And if they are equal to the 0, it means we are not hitting the correct layer. Bit shift operator means we are just shifting bits to the left side. And yeah, that's basically it. If any questions to it, just feel free to ask anything related to this topic. I will be more than happy to provide you answers. Alright guys, so that should be it from this lecture. We'll continue. The next one will be again implementing some new features. So guys, I hope to see you in the next lecture. Cheers.